organize such activities. First of all, it is very important in this pandemic, the situation which have been created all over the globe, that lot of transformations is taking place in almost all walks of the life. And particularly when our academics has been suffered a lot. There is no school, colleges are almost closed, research laboratories are almost closed. Then definitely we have to switch over to certain alternative platforms for educating our children. Research laboratories are almost closed, budding engineers. That's why lot of transformations are required, not only in the specific domain of the engineering, but in almost all domain of engineering. Apart from this, the role of the IT and computer professional becomes more prominent because ultimately you have to use lot many tools which will be beneficial for other disciplines as well. So transformation which are normally taking place in the field of the information technology, in the field of the communication, because communication is very important these days. Unless and until you have efficient techniques of the communication, your goal will not be achieved. So whatever new is coming in this domain, what we have to do, what we have to study, what we are studying, it looks that we have to go for a brainstorming to discuss, to deliberate that how these transformations can be beneficial to the industries and to the society as well. I belong to the chemical engineering domain. So chemical engineering also plays a very important role during this pandemic because there are a number of the items which are being talked nowadays, that you have to use these surfactants, you have to use these cleaners, you have to use these moisturizers and other things which are useful to keep the viruses away from the different types of the surfaces. So different types of the surfactants are basically required to be used to protect ourselves from this pandemic. Ultimately, we have to change our lifestyle. So not only the usage of these materials which protects you from the viruses, but also you have to think over that what food habits you have to adopt during this pandemic, what exercises you have to perform to keep yourself healthy. Unless until you are healthy, you cannot perform your duties as a citizen, you cannot contribute for the society, and you cannot do justice with your profession also. So I'm confident that the participants will definitely be benefited with the deliberations which are going to be made today, and we will be having blessings with our Honorable Professor D.S. Johansen, who has always been a source of the inspiration to all of us. And I wish success for this webinar. Thank you very much.
Thank you very much, sir, for your motivation, guidance, and moral support. Your influence can never be erased. It is the supreme art of the teacher to awaken joy in creative expression and knowledge. Thank you, sir, for being with us on this beautiful day. Thank you very much, sir. Going ahead, let me shortly take you to the agenda. The webinar has two sessions. Inaugural session where we are currently, and then technical session. Dr. Anil Kumar, State Project Administrator, State Project Implementation Unit, Uttar Pradesh, will deliver opening remark of the webinar. Afterwards, we will be blessed with chief guest address by Professor D.S. Chauhan, Founder, Vice Chancellor, UPTU, now AKTU, Lucknow. Dr. Mahavir Singh Naroka, Nodal Officer Academic, SPIU, Uttar Pradesh, will propose vote of thanks of this inaugural session. It will be followed by technical session, technical keynote talk on system architecture and design with real-world examples will be delivered by our expert today, Engineer Shaurya Kant, Software Engineer, Microsoft India, Hyderabad. Then the session will be open for question and answers. Feedback link will be given in chat box. Questions can also be put up in chat box, which will be taken care by us to resolve through expert. At last, Engineer Shashank Gupta from CS Department BIT Jhansi will propose vote of thanks. Count your rainbows, not your thunderstorms, he says and inspires. Yes, Dr. Anil Kumar, State Project Administrator, State Project Implementation Unit, Uttar Pradesh. Dr. Anil Kumar has rich experience in field of academic and general administration, quality assurance, regulatory compliance, accreditation, industry institute partnership, international affairs and administration of examination, assessment and certification. He has around 35 years of experience from industries to academic administration. He also has served AICT MHRD as Deputy Director Regional Officer before joining SPIU Uttar Pradesh as State Project Administrator in June 2018. For implementation of TechTube 3 project in Uttar Pradesh, he was Secretary and Director General in charge and Deputy Director General of Institution of Engineers, India. We are blessed to have such a distinguished personality among us in this webinar. Sir will deliver the opening remark. Over to you, sir. Over to you, sir.
Thank you very much, Sanaji. Thank you very much, Sanaji.
Thank you, sir. Yeah.
Can you hear me, madam?
Yes, sir. Yes, sir. Okay. Yes, sir.
Sir, it is indeed our great pleasure to be part of this great webinar. When the series on transformation of technology series was conceived by BIT Jhansi, and they started every week one discipline of engineering, transformation taking place in that particular discipline, asking experts from the industries and some academic leaders as well, so that budding engineers, more particularly third year, fourth year students, can learn more about the transformation taking place in that particular domain. Sir, we truly say that there have been a massive transformation in engineering and technology almost in all disciplines across the globe, and same is taking place in India over the last decade. There has been application of multidiscipline to a problem, and even there has been a fusion of two disciplines or more taking shape of a new discipline. Even biological sciences are coming to the engineering and technology, and many researches are going on such fusion of science and technology. Even engineering and biological science together is evolving a new discipline. Similarly, in every domain, lot of transformation is taking place. Now, even people say that transformation of technology even more faster than we can imagine. Then we can assume how fast we have to move to catch the transformation taking place, otherwise it will become irrelevant. The basic objective of talking about on this transformation is try to understand whether the existing skill area becoming redundant. If so, what are the new skill area which require large number of trained manpowers in the new and emerging skills? So we have to prepare accordingly, and we have to become not only relevant in the country, we have to become the leader of the world only when we can gradually transform ourselves as per the changing need of technologies, as per the changing transformations, and developing a high skill manpower in the future and emerging skills. We are now passing through a digital era, a step toward the advancement of technologies in the most audacious ways, from internet-enabled smart devices to autonomous vehicles, and from blockchain to artificial intelligence. Digital transformation is influencing every aspect of our life. By channelizing the digital platforms, enterprises are getting tremendous benefits and accomplish their business objectives. To simply state that digital transformation means it can be defined as a change that is happening through fast adoption of technologies, right from the change in the work culture to dramatic impact on the business goals and improving the lives of the people. The young expert from Microsoft, Mr. Sorekant, and a triple IT Gwalior master's degree holder will be delivering his expert talk on system architecture and design. When we talk about the architecture of a software, we talk about a plan that describes a set of aspects and decisions that are important to a software. This implies taking into consideration all kinds of requirements, performance, security, etc., the organization of the system, and how the system parts communicate with each other, whether there are some external dependencies, what are the guidelines and implementation technologies are, what risks to take into consideration, and many more. Similar to how civil architects or civil engineers have an excellent understanding of how bridges need to be used and how much space they can take, system architects are proficient in understanding how computer systems need to be used, how much space they can take, and what is needed for the system design to hold on. In a similar way, a good system architecture finds a balance between what often are competing requirements, security versus performance versus usability versus maintainability. Eh, we are more blessed that we are having the founder vice chancellor of UPTU and now AKTU and Uttarakhand Technical University. Not because he is the founder vice chancellor, more because he has been one of the few early computer engineering academicians and researchers who who brought into India the basic foundations and a curriculum in the field of computer science and engineering. Over the last 40-45 years since he started his journey with his vast experience, not only in the field of this, in the field of technical education administration, policy planning, and regulatory compliance will be definitely beneficial by his guidance and his blessings. With these few words, I wish this webinar a grand success and express my heartfelt thanks to the chief guest of the session, Professor D.S. Chauhan sir, as well as the entire BIT fraternity headed by Professor V.K. Tyagi ji, Director, and more particularly Sahnaz ji, who have been instrumental to make this program a reality. I will also express my thanks to my team, Mr. Mahabir Singh Daruka, my all other colleagues who have been part of this organization, along with Sahnaz ji and her team. They are making it successful. Thank you very much. With these few words, thanks again. Jai Hind, Jai Bharat.
Thank you, sir, for your cooperation and support. During this pandemic, we have conducted many webinars and one international FDP also jointly with SPIU Uttar Pradesh under your guidance. You have influenced us in such a positive way, words cannot express my appreciation. You are truly an inspiration, sir. Thank you very much, sir. Failure will never overtake me if my determination to succeed is strong enough. Yes, he says this and he believes this. Yes, chief guest of this webinar, founder, vice chancellor, UPTU, now AKTU, Lucknow, Professor D.S. Chauhan, sir. We feel proud to have with us our founder, vice chancellor, Professor D.S. Chauhan, sir. Sir, you hardly need any introduction. You have made all of us proud by your distinguished work in numerous capacities. A man of distinct vision and a fountainhead of illuminating ideas, an ideal of knowledge, experience, and inspiration to all of us. He is a man who looks forward to reform the whole education sector with the aid of technology. Professor D.S. Chauhan, founder, vice chancellor, AKTU, Lucknow, is a renowned academician and a well-known expert and technologist in computer science engineering in the country. Professor D.S. Chauhan has established and transformed the university with good governance, which he only can do. He is a man of reforms. He is an able administrator. He is a great philanthropist and always working for taking the academics at new heights. Professor Chauhan is a true visionary with innovative qualities. His multifaceted personality has provided leadership to the teaching community and contributed immensely for the development of nation. He is a man of developments. Professor Durg Singh Chauhan, founder, Vice Chancellor, Uttar Pradesh Technical University, Uttarakhand Technical University, Lovely Professional University, JP University of Information Technology, and Secretary General Association of Indian University, and presently Vice Chancellor, GLA University, has his postdoctoral work at Goddard Space Flight Center, Greenbelt, Maryland, USA, and alumnus of BHU, NIT, Tiruchirappalli, and IIT Delhi. He served at Banaras Hindu University since 1979 till April 2013 as assistant professor to professor and served as director KNIT Sultanpur. He is a member of AICTE Council and has been member University Grants Commission. All the universities he has served brought them at international scene by his specific contributions. Besides many other contributions, the social service is his mission throughout his life and engaged in upliftment of tribal areas specifically since 3 decades. He has been admired for his number of contributions in society. Best Engineer Award by Institution of Engineers, Lucknow 2001. He has produced 32 PhD, including 2 DSc and 175 research papers published in international journals, national journals, and conferences of repute. Chairman Advisory Committee of 4 deemed universities, jointly authored 4 books and 100 articles published in technical magazines and newspapers. He has been member for IIT NIT Council, Government of India. Member Search Committee of half dozen universities of various states. Member IEEE, FIE, Life Member ISTE, Member ACM, Member SIAM, Academic of International Bodies. Born in 1949 at Dholpur, Rajasthan, though his parents hail from Mainpuri, Uttar Pradesh. There are n number of achievements in his credit, but he himself is an institution. I request you, sir, to take this digital platform and fulfill our knowledge. We are honored to listen to your insightful speech as chief guest address to motivate this galaxy of intellectuals, sir. Over to you, sir.
Thank you, Shanwaj. Respected Director of the BIT, Dr. B.K. Tyagi, and Dr. Anil Kumarji, who is always very exciting personality, and the keynote speaker from the Microsoft. I want to trace the history of our relation with the Microsoft. I think Dr. Divakar Yadav from IIT and one of the girl from one private institute, Ramswarup, they were sent to the Malaysia when Microsoft wanted to, train few persons from different universities. That was my first, what you call the endeavor I made. That 2 persons were sent to the Microsoft that conference. Myself also joined them when Bill Gates came to Malaysia, and there was a 2-day session for .NET, ASP.NET, this technology. Various experts came for, and they invited around 12 professors from the India, and I also joined them. And that time I met Bill Gates because he addressed the entire audience in the beginning in the hall. So there were 2 encounters, and Dr. Jacob, who was licensing, in those days, he was at very senior position in the Microsoft. Later on, where he has gone, I don't know, but he was the person who requested me to carve out at least 1 semester in the entire 4 years, where various, courses of the Microsoft, IBM, Satyam, whatever they wanted to, initiate. So I thought there's no problem because out of the 8 semesters, we have got a lot of optional subjects. We can accommodate the recent trends, the recent, technology of the various multinational companies. And Microsoft is a big name in the computer, the world, because today when we see that the PC culture has been extended to every, uh, the learner, students, scholar, everywhere you can see. This is endeavor made by the Microsoft. Now, the recent transformation of the knowledge, as our Anilji told, that communication is also very big, uh, at very big stage it needed, because communication in India, like country like India, where communication link is very poor. And when I was designing for our, Uttarakhand, the that's knowledge, connectivity, it was very difficult in the hilly areas. So India has got some problem in some areas because these mountains and hilly areas, then their tracking, their roads, then blocking of the signals, so many things are there. So the India has to take a lot of, a different kind of the efforts to reach out all the villages, the entire blocks, tehsils of the various, states. Now, this program today you have taken from the Microsoft, and they will give keynote address on the recent, the transformations in the computer engineering. Because nowadays, you can see that everything is converging on the computers. When we were student that time, the basic was taught. Even earlier to that, when the microcomputers were taught, when this operating system was designed and it was integrated with the microcontrollers, it became a very big, advancement in the field of the technology. And now we can see that from mainframe, because we worked, a lot of work we have done on the mainframe. When I was a student of the PhD, that time we were working on the mainframe computers. PC was not in those days very popular. Only the mainframe computers, ICL, IBM, DEC 10, they were the most, mostly used various places. IIT Delhi was using ICL 2940, and we were all working on those computers. But just within short period, within 2 or 3 years, the PC arrival in various departments, was very, very common. And even switching from mainframe to the personal computer was little difficulty to those scholars. But now you can see that while you are traveling in train or the plane, anywhere you go, you can see. But one thing is very common, that 3 things you have to always learn: the data structures, coding, programming, and then as I was more exposed to the artificial intelligence, because while I was in America, I did work only in the artificial intelligence and the image processing, because my work was mostly on robotics, and that robotics was not a ground robotics, but the robotics that was used for satellites and various, operations in the space. So now, after 30 years, what I am watching now, a lot of things has gone in. AI also platform completely changed. In those days, whatever we read, AI, and nowadays AI altogether very different. So all the transformations in the various field and application, Now we have to be very up to date, because now when we are doing coding and then data matching and then the results and output also destined to be different when there will be a different, the programs. So the computer science now become the part and parcel of the education. Everywhere it has got penetration. The computers for civil engineers, computers for electrical engineers, computers for electronics, all walk of life, as he was telling, that bio informatics, even you can take, any model. Now the compilers are also coming for D1, D2, D3, D4. Now various, technology also going on a visual mode also we are going. So I think Microsoft has got a tremendous evolution, because since 1975 until today, you can see the complete evolution of this. Bill Gates is hardly born in 55, I think, and his wife is also 64 born, and his friend must be that Paul Allen. These all three, if you take, even Steve is also 1955 born. All these 4, 5, the big people now you can see, they have their tremendous impact on various countries and products. And we can see that when this integrated circuitry started coming and the transistors, accommodated in those integrated circuits in millions, then this become possible to take the shape of computers very small, and the process also can be made fast. And now you can see the wonders around the world, that the complete technology has got a various, specialization. The hardware has gone 20%, the software gone 80%. You can see the job market also. The 80% jobs are mostly in this software. Now, software is also a big, transformation. The programming is a big area, like a data science, and programming is also going to become science. Now you can see when this .NET was the common platform for various languages, for C Sharp or various language, objective and a simple, C language, C++, and C Sharp, various language at one platform you can work. So the platform is also very important, that if you can all work at one platform, the one technology is sufficient for integrating each other, and we can, bring the fruits of this transformation, because this computer technology going very fast way, and Microsoft, from MS-DOS operating system to the Windows 10 today, you can see a lot of, now they are also moving towards, the mobiles, and they want to, work in the mobile field. And the complete, if you just see the history of Israel, the complete evolution of the Israel, because I think, uh, if I am not wrong, the Bill Gates belongs to a Jew community, as I was sensing in America while I was there. And they have done tremendous work in the Israel. From A to Z, they have transformed completely, Even this cloud computing or the security on cloud computing, you just take the entire, the Israel computer technologies, you can see the impact of the Bill Gates over there. So what I feel, this Microsoft has got a very wider, the area and products, licensing, and then, a common platform. They are working in all field, in data, transformation, they are working in programming transformation, they are working in the AI. Now they are going towards visual also, because this visual C++ and I think I have seen now the quantum computing is also a field, while our BK Tyagiji was talking, because quantum computing is mostly applicable in the chemical engineering, because while you are doing a lot of, what you call chemical testing and the liquid fluid testing, various transformations, the quantum computing is very useful for that. So I think all the transformation will be exposed later on in a common textbooks, because while it is coming for teaching or while you are doing for research, there is a lot of gap between research and teaching. Research has got a one aspect, they want application very fast in the industry, but the teaching, you have to evolve, from uh, the person who is not knowing much, and he must slowly and slowly learn and become expert of dealing those technologies. So in teaching, there must be a textbook, and the textbook must contain the more application and examples, and where the student can learn various, aspects of the examinations. He can be tested, his learning can be tested, he can be examined whether he has learned the full subject or not. So there are so many aspects of the, what you call this pedagogy and pedagogical fitness of the text or the research into the learning, then it will come for teaching. So I think the Microsoft has gone from research to teaching, and teaching to again to the research, but they have a tremendous, impact in the computer science technology, because I have seen them. You can take even any their CEO, and every CEO has got a big, leap in the field of the computer science. I have realized their contributions, and I hope when he will give the keynote address, because I will not that much be sufficient or efficient for giving Microsoft, the dimension, but the experts from the Microsoft will give, and the faculty will be always benefited. The students will be benefited, because these new technologies, their terminology, their dimensions, even you have heard, then you will have interest for learning them more, and then you can just search them in various ways, because there are so many articles you can find in magazines, journals. Now online also journals are available. You can just read whole night, or you can just learn from the various persons that what are these things coming into existence within short period. And you know that the computer science going to stay. When they have stayed almost 1989, it become this batch sequence, communication made possible the computers more viable in communication because of that communication. And today, in 30 years, the way it is, growing 15% to 30%, rise in the application, and economy also wonderfully contributed, because you can see the billions and billions of dollars, the income of these companies. Even if you take the Microsoft, the economy, you can just see there is gigantic economy of very big, size. And even the employees of the Microsoft, I think, must be more than 150,000. So this dimension, it is not only the computer science transformation, the transformation of the life, because the employment is also a big need. When Microsoft can give, the job to the 150,000 people, and you can see then later on application, how many jobs indirectly given by the Microsoft. So I think many dimensions of any transformation can be seen, but the knowledge is very important, and knowledge is very useful, and anything that is useful may be also harmful. So knowledge must be precisely understood. It should not be just like you are half-heartedly understanding anything. Then when you are implementing, it will go differently. Because we have seen when billions of dollars we are spending on satellites, going on Mars and various, planets, a single mistake can create, the harm of the billions of dollars. So therefore, knowledge is not only a knowledge, it is what you call the economy of any country, economy of any nation. At the same time, engagement of the people, because people are making this universe, and this entire, the world must be always engaged in good pursuits, and the computer is one of them. As earlier, physics, chemistry, chemical engineering, or various engineering, then medical science. You can take anything that involves humanity, involve, humanity for extension. And extension does mean not only knowledge, economy, but the dignity of life and uh, the self-respected life with more knowledge that they can express in their life. So today, I'm very happy that Sanwas called me and she invited me. Then my student, that Mahavir Naruka, was also my student. While she was reading my biodata, it was must be a very old biodata, because around 56 PhDs I guided and 4 DSc. So it must be, I think, the halfway you have introduced my. And he told me that there will be one webinar if you can be chief guest. There's no problem. I'm sitting idly here, so I can express my views. But Microsoft, I have personally gone to Malaysia with 12 more professors from across the country. Nupur Prakash was also with us. One, the IS officer, he was looking after the IT of the Punjab, was also with us. So I can just remember how many people were there in that gathering. And Bill Gates, he addressed the whole meeting, and we stayed for 2-3 days. And .NET was, the learning of the .NET was targeted that time. It was a common platform for various, programming. So thank you very much that today again I came across the Microsoft. And when I joined as a vice chancellor, that time also the Microsoft approached me that you have to take, various courses in your fold. And I adopted one semester only for, the computer science technologies coming from the multinational companies as a subject. And I hope this seminar will be very helpful for not only VIT, VIET, but those who are linked with today this webinar. They will know that Microsoft is working across the world, and they are doing very pioneer work. There are only a few, the multinational company, they are working really in the computer field. Thank you very much.
Thank you, sir. Difficulties are opportunities to better things. They are stepping stones to greater experience. Perhaps someday one will thankful for some temporary failure or a problem in a particular direction. When one door closes, another always opens. Sir believes this. He made our state, our country a great opportunity for us to way ahead. I am extremely sorry, sir, for uh, spelling your dictating your reading your biodata in a
No, this is
narrower way.
all.
Yeah, extremely sorry, sir, for that. You told that you have guided 56 PhDs and 4 DSCs. Yeah, it may be on paper, but let me tell you that you have guided number of PhDs, unlimited PhDs. They may not be in the form of certificates, but there are number of PhDs. Sir, I wholeheartedly thank you for your inspiring and encouraging words. We wish to express our gratitude to you, sir, for being with us on this event. Thank you very much, sir. Your thought-provoking address set a perfect platform for us on this important topic of today's webinar. Thank you so much, sir. Prior to move ahead with technical session, I would request Dr. Mahavir Singh Naroka, Nodal Officer Academics, State Project Implementation Unit, Uttar Pradesh, and co-coordinator of this webinar to propose vote of thanks of this inaugural session. Over to you, sir.
Thank you, ma'am. Thank you very much. So on behalf of the State Project Implementation Unit, Uttar Pradesh, the Bundelkhand Institute of Engineering Technology, Jhansi, and my own behalf, I would like to convey my regards and thanks to our mentor, Guru, and the today's chief guest, Professor Dur Singh Chauhan ji, the founder vice chancellor of Dr. APJ Abdul Kalam Technical University, which is formerly known as Uttar Pradesh Technical University, for accepting our request and agree to be part of this event and spare time from his busy schedule. Thank you, sir. Your guidance and blessing always inspire all the academicians and researchers. I like to thank our co-organizer institute, BIT Jhansi Director, Professor V.K. Tyagi ji, who is always provides us for this kind of opportunity to interact with people like you. I would like to convey my thanks to our distinguished expert for the session, Engineer Shaurya, who is the software engineer at Microsoft India Limited, Hyderabad, for accepting our invitation and deliver a very informative talk on this subject and making this event interesting and meaningful. I would like to thank Dr. Anil Kumarji, who is the State Project Administrator SPI UP and the main driving force behind the success story of the SPI Uttar Pradesh, for his guidance and the support. I would also like to convey my thanks to the dynamic force behind this event, Dr. Sahnaz Ayub ma'am, who is the Dean R&D, BIT Jhansi and Webinar Series Coordinator. I also appreciate the support of Professor D.K. Srivastav ji, Head Electronics and Communication Engineering, BIT Jhansi, and Engineer Shashank Gupta ji, BIT Jhansi, SPIU officials, Mr. V.K. Singh ji, Mr. Vineet Surana, and others who are involved directly or indirectly in this event to make this success. I would also like to convey my thanks to Ministry of Education, the World Bank, and the NPIU officials for their contribution toward the success of the event. At last, I thanks all the participants who are attending this online event from various corners of the country. Without support of them, the success of this event will not be possible. So once again, thanks to all for joining us. Jai Hind. Thank you.
Let me thank Dr. Mahavir Singh Naroka for his wonderful and tireless cooperation to this webinar and webinar series. Thank you, sir. A door is much smaller compared to the house. A lock is much smaller compared to the door. And a key is the smallest of all. But a key can open entire house. Thus, a small thoughtful solution can solve major problems. Yes, he believes this. Engineer Shaurya Kant, our today's expert. Engineer Shaurya Kant is MTech in Information Technology from Indian Institute of Information Technology and Management, Gwalior. Currently working as a software engineer in Microsoft India Development Center, Hyderabad, part of the Office Core Tech Division. Earlier, he worked with Samsung Engineering Lab R&D, Noida, Snapdeal Gurgaon, and Lithium Technologies, Bangalore. Publication to his credit, he has proposed algorithm for effective traffic merging and scheduling at a two-lane merge for different traffic conditions for intelligent vehicles at University of Reading's UK. He published research paper in the area of artificial intelligence and neural networks. He has proficiency on the topics system architecture and design with real-world examples, system scaling, database sharding, design patterns. Today, he will deliver a talk on system architecture and design with real-world examples. Over to you, Engineer Shauryakant.
Thank you, Dr. Ayu. I hope I'm audible.
Yes, yes.
Good evening, everyone. It's really my honor and privilege to be a part of this platform where I will sharing my dice with eminent personalities like Professor Chauhan and Professor Tyagi. My heartful regards to both of you, sir. Professor Chauhan, really, it was very insightful to hear from you about your past experiences with Microsoft and also the knowledge you showed about how technology and how the transformation has changed within years. Truly, it was great to hear these things. I would like to thank Dr. Anil Kumar from SPA for presenting this opportunity to me. I would also like to thank Dr. Ayub and other members of the organizing committee for organizing this event. So as Dr. Ayub has already briefed about me, so I need not to say anything more. So I just see totally having an experience around 10 years is the industry experience that I'm having. And currently I've been with Microsoft for the past 3 years. And it's been a great that we have a industry and education collaboration. It's very necessary about seeing the future. And if we want India to grow as a knowledge economy, as a knowledge hub, it is very important that we keep adapting ourselves to the changing trends. And importantly, our education system should keep on changing and keep on adapting. Based on this, let's start this today's knowledge session that we'll be having. So today's session is basically on system architecture and design. This is one areas where a lot of companies, be it be Microsoft, be it be Amazon, be it be Google, all are heavily investing in this particular area. The prime focus of whenever you devise a product or whenever you design a product is basically on how you architect it, that is system design. So system architecture and design basically is a base, what we call when you create a building. In Hindi, it's a very favorite term, Neve. So it's basically a base on which you design your system. So today we'll try to go through this, that what actually is system architecture, what is system design, why it is important, what things we should keep in mind. And I'll share some of the very details of a system design of some large applications like Twitter, how they are designed, what their makers thought in mind when they actually went about designing the system. So currently what happens, there has been a subtle changes in the trends in the past couple of years. Earlier focus was a lot to be on programming and algorithm. Though programming and algorithm constitute a very basic part and very fundamental part of computer science, but with the advent of changing trends, changing technologies, the shift has changed predominantly on architecting the system. Means you should design a system to a level so that it caters to your need is what the things have changed. And companies are heavily investing in it, be in the R&D, be in the specific teams or something. So this area, particularly today, is of great concern. The permanent reason being things are changing. The technology that you're using today might become obsolete 3 months down the line. But you cannot keep on changing your system. You cannot keep on changing the architecture of your system because it comes with a cost. It comes with efforts. So the stress is that to create a system, you create an architecture that even 6 years down the line, 5 years down the line, the technology changes, the system is still able to work and cater to the needs. So let's go through the basic of the system architecture. So is this visible?
Yes.
Yeah. So we'll talk about what is system architecture, and then we come up a topic that is system design. So there's a difference between a system architecture and system design. Then we will go through some of the concepts of it, how the real world is managing them, what are the problems that are associated, and all these. Especially for students who are in final year or maybe preparing for placement, this is one area that is catching attraction of many companies. You may be asked some knowledge on this when you actually sit for your placements or something apart from your coding and algorithm skills. So let's see. Let's hope this we go through this thing and it becomes exciting and especially beneficial to students and the entire people here in this meeting. So let's start with it. So what basically is system architecture? So if you go through this, so I've tried to brief the. It's still a very detailed topic, system architecture. It's basically a course topic in one of foreign universities where there are especially PhD thesis and MTech thesis have been carried on these areas. I've been trying to briefly touch down these topics, before the points at what actually is, so that we can have a brief understanding and then we can go through this session. So what is basically system architecture? So system architecture is basically a conceptual representation of the components and subcomponents that reflects the behavior of a system. So basically when you go about coding something or when you go about developing something, you have to first understand that what will be the components of your system, how will you code, what component will interact with what components, how things will happen. So this is all we termed it as system architecture. It is the structure of the system which consists of your software component, the externally visible properties of these components, and the relationship between the components. So in other words, suppose you create a building, the like way you design a building, you need to understand the various components of this building. Like your building is going to have a basement, your building is going to have a lift, your building is going to have floors, it will have wirings, it will have electricity supplies, it will have water supplies. Similarly, when you design a software component, however basic is your software, you need to have these things in mind. That okay, what will be the interfaces there, how the things will interact, what were the components. Coding basically drills down to the very last level. Coding is basically when you're aware of the components, when you know how the components will interact, then basically we proceed with coding. But before that, a lot of things happen. And the most important thing that happen is visualizing these components and establishing a connection between these components. So basically, system design could be seen as the application of system theory to product development. So basically, system design is theoretical. You come up with a theory that, okay, this is my system. These are the things that will be present in my system. This is how the user will interact with the system. If the user interact with this system, how this system will interact with other system. So this is basically a theoretical thing that we conceptualize. And based on this conceptualize, you then code and then make it a system. So this is how it works. So let's very sample example of what is a system. So let's take example, for example, Make My Trip or yatra.com. So these are basically booking systems, rather we say in technical word. So in systems, you have a user, basically us. We go to our computer. This is basically the browser. Type booking.com. Then we add our details and then search for flights. So this searching, it directs to this particular system. The booking.com has a system. This system, then it directs it to services. We have a services that will, figure out all the flight details and everything, and will verify your address, do certain verifications. Then these services will talk to resources. You create a resources where you have database of all the things. That okay, these are the flights, these are the timings. Suppose from Delhi to Bombay, these are the available options. So these are the systems basically. These are the components of the system. One component is a user. The other component is a browser. Then we have an application layer component. Then we have service which is a component, and then we have resource which is a component. So this is basically a conceptual representation that how these components will interact with each other. Which component will ask what from other components. So this is basically what is termed as a system architecture. So it's a very, very high level architecture. It's the system architecture has many things. We have a high level design. We have a low level design. So we'll come to those, but just to give an understanding that what we mean by when we say a system architecture, it is basically this conceptual representation. So moving ahead. So what happens basically when we, go about designing a system? What we mean by designing system? Suppose you go about implementing any system, a simple web server system, or a simple mobile application. So how it happens in today's industry? A lot of things has changed, a lot of models were proposed. We had waterfall models and many models which are there in the courses there. But actually in real world, since I've been working with Microsoft, so what actually is followed in Microsoft? So these are the steps that are basically followed in Microsoft. These 6 important parameters is that actually is followed when we go about, designing any product or building any product. So when I say system or when I say a product, just take it as a similar thing. So first phase is what we have is a system requirement phase. Then we have a system design phase. Then we have analysis and evaluation phase, followed by an implementation phase. Then we have a testing phase, and then we have a maintenance phase. So today's topic is basically will be covered on the second phase, system design. So first to gather requirement at what we want to develop. what will the users, what will these use cases. So this comes under requirement, acquaintance. Then when you have all the requirements, you go about conceptualizing the system. Okay, what are the things will be present in our system? Like I showed before for the booking system, how things will interact, what will be the interaction with the components. Once that is done, then you do an analysis of this and do an evolution of this. Then you do, basically this is a feasibility study, the analysis and evaluation. That okay, what are feasible, what not are feasible. And then you go for the actual coding where write codes for those modules and how all the calls that we make. So once that is done, then the system goes to a testing phase. So actually you see of all these 6 things, coding is actually 1/6 of the part. 5/6 of this is very different things. So in today's world, coding actually constitutes only 1/6 of a product. 5/6 of a product is basically related to your testing, related to your designing, and related to your requirement analysis. So once you have implemented your system, your system will go for testing. And when the testing is done, you roll out to the people, you roll out to the users, and then you need to maintain the system. So system design is directly linked to all these phases. If you have a concrete system design, you will be able to do a proper analysis. You have a concrete system design, you will be able to implement it properly. If you have a concrete system design, you can be able to maintain it properly. So nowadays, the basic stress that organizations are giving it or dwelling into the fact is that we should come up with systems that require very less maintainability. So basically in software engineering, there are 2 profiles. One profile is a developer profile. One profile is a tester profile, that we call QA, quality assurance. Microsoft, what they have done is that they have removed this particular profile called tester or QA. You won't find any testing or QA thing in Microsoft. When Satya Nadella took it as a CEO of Microsoft, the first thing he did was that he ensured that we remove this testing and QA thing. There will not be testing and QA separate engineers for that. The developers will only be responsible for testing, and they should come up with such systems that require minimal testing and minimum maintenance. Because test engineers are basically responsible for testing and maintenance. Because whenever a customer face any bug, they raise it to the test engineer. Then the test engineers go through those and test in the system. Then they report to the developer. So now the prime focus is that to invest so much in system design itself that these 2 phases, the system testing and system maintenance, becomes very minimal. So that is why the system architecture and design is a very important component. So there's a very short video that I'll sharing just now. This video will detailed about how things are actually done in an organization.
In order to understand what a software tester or quality assurance analyst...
This is audible, right? Hello?
Yes.
The video is audible, right?
Yes.
Okay, yeah, okay, fine.
does, you first need to understand the process by which the software is conceptualized, developed, and maintained. This process is known as Software Development Lifecycle, or the SDLC. There are 7 key points to understanding the software development lifecycle. Phase 1, planning. Phase 2, requirement analysis. Phase 3, design. Phase 4, implementation and coding. Phase 5, testing. Phase 6, deployment. And Phase 7, maintenance. So it all starts with this guy, the customer. He's the guy that has the business idea for our invoice application and the money to get it started. He's going to reach out to multiple different tech companies until he finds one that he likes. Finally, he's going to meet our company's product owner or our project manager. They are going to discuss terms of their agreement, sign a deal, and accept the project. This will move us into the next phase, planning the requirements. Together, the customer and the product owner will outline the requirements of the application. Let's imagine that the requirements that they've both agreed upon are as follows. 1. User registration. 2. Login. 3. Log out. 4. The dashboard landing page. And so on and so forth. Throughout this course, we'll be running multiple iterations of the SDLC, to which new requirements and new features will be added. Now that we have the outlined requirements, let's take them and move on to the requirement analysis phase. Here's our team: operations, developers, product owners, and testers. We'll all meet up in an office for a few hours and define each outlined requirement and give more planning details.
So once we get the details from the customer, we used to do a very brainstorming session that happens in organizations where each stakeholder is made part of, like the developers, the operations, the testing team, the product manager. So the product manager is the first interface that we have between a customer and the company. He is responsible for making a deal with the customer, understanding the requirements. Now he meets out this requirement to the operations, testing, and developer team. Based on these only, brainstorming is done, how to go about the product, what is feasible, what not is feasible. And after this only, we come to the designing part.
Let's start with requirement number 1, the user registration. We'll need a username input field, a password field, a checkbox to accept the terms and conditions, a submit button, and the ability to save the user into our database.
This is a very basic application that a user just need to, have his username and password, and then that should go stored in a database. It's a very simple application. So for this, if the client comes to a company and says that we want to develop this application, so this is how things are refined. That okay, there will be a username field, there has to be a password field, there has to be a checkbox theme. So this is how the brainstorming session is done, and the product is visualized.
Then we'll move to requirement number 2, the login. We'll need a login page to allow returning users to log back into our system. For this, we need another username input field, a password field, along with another submit button. From this, we'll need to read the user's information out of the database and log them into our system. Requirement number 3 will require a logout button, usually located around the same area where the user was logging in from. When they press the logout button, it should clear their session out of the browser to prevent other people from returning and logging back into their account. Finally, requirement number 4, the dashboard. This will essentially be the homepage of our application. After a new user is registered, they should be redirected to the dashboard. Also, when the user logs in with the returning account, they should be redirected to the dashboard. For our first SDLC, I will keep the requirements easy. In upcoming videos, we'll dive further in with much harder customer requirements. Once all of the requirements have been analyzed by the team and defined, the product owner will take all the defined requirements and create tickets in a project management system. From here, we'll move into the design phase of the SDLC.
So in organization, what happens is that when you are clear with the requirements that these things are to be developed or these modules are to be present, a ticket is basically created. So this is an agile system. This again is a very complete different flow, but this is an agile system where the product manager, after syncing with different stakeholders, comes to the following conclusion, and the things are locked that these things we need to create. He creates an action item for all those things that we call ticket in general organizational term. And these tickets are assigned to the teams that, okay, this is your ticket, start working on it. And once it is done, close the ticket. So this is how these things are followed.
The design phase takes all the requirements and starts to plan the product. The design phase may include the business rules, the user interface layouts, color schemes, what programming languages.
Now in designing phase, we actually drill down. We just now hear the actual work starts that, okay, how the screen should look like, what should be a layout of the screen, what should be the color of the screen, what languages we should prefer, whether we should go with Java or we should go with .NET. So all these things are now then taken care into the designing phase.
To use frameworks, system server design, database relationships, architect of the application, mobile aspects, supported browsers, and much more. Next, we'll discuss the implementation.
So we see that of all these things, the most important things that happen are in the design phase, where actually the entire things are meted out, like what will be required, what will be the modules, how the databases will be created, how they will interact, how many servers are needed, what type of servers are needed, coding languages, everything is taken part into design phase. So this is why if this phase is not apt, in this phase, if we miss any decision or if we go with certain decision that is not correct, it will have impact on all the subsequent phases. You will not going to have a great product if this phase, if there's any lacuna in this phase. So that is why a lot of things, a lot of emphasis and nowadays is being put basically in this phase.
And the coding of the application. The implementation and coding phase is where everything starts to become fun. The operations team will set up the physical hardware for the servers.
So as it is said in the video, so when you actually go for coding, it's basically fun because things are actually being cleared in the design phase. So the coding is, is just one 600 component. And when you have a proper designing, coding is just about, conceptualizing the thing and bringing it into the picture.
The developers will start writing the code. The designers will continue planning the user interface. And the testers will analyze the requirements and start building test cases for their test plans. Even in
Microsoft, basically, we have, when the designing phase is over, we have designed the module, we are clear with the components, and we are clear with the selection of languages and all that. We just give it to the development team. Now the development team basically has three parts. One is the developer who will actually sit and code. One, you have a UX team. Now this UX team there's no concept of UX team 5 years, 6 years down the line, but it has recently come up. Where in UX, you will have designers. The designers will actually come out with the layout, at how the layout should look, how your screen should look, what should the images in the screen, suppose you are entering a username in a box, then how the box should appear, where the box should appear, and all these view related things are taken care by the UX team. So UX team creates a view type of thing, they come to the developer, and it's been the work of the developer to code that thing. So once these two things are clear, then the testing teams comes into picture. But as I said earlier, in Microsoft, developer itself takes care of the testing also.
At this stage, testers are incredibly valuable. They start to imagine the usability of the application and see how everything flows together. Sometimes while writing test cases, they can discover things don't make sense and help redesign fundamental flaws in the early stages of the application.
So when developer proposes the first implementation and it goes to the tester, then the tester is to do a rigorous testing. It is the responsibility of the testing to make sure that whatever client requirement is there, it is met and every system is up to the mark. Then if they feel anything is not correct or any redesigning need to be done, then they again go back to the developer for this. So this process is known as a cool-off period, and it takes a bit amount of time before the system actually goes to the user.
Next up, we'll be discussing one of the most important phases, which is the testing phase. So why is the testing phase so important? Well, imagine that the developer has finished coding some of our new features and our requirements. We found that when the user logs out, that it's not actually clearing the session in the browser, and that another person can walk up to their computer, click the login button, or click the refresh on the page, and they gain access to their account, get access to all of their money, and start making payments on various things. It would be a huge and expensive, terrible bug that would get released if we didn't have testers to test these types of things beforehand. So what does a tester actually do during the testing phase? Now that we have the servers all set up and the database is set up, developers have finished coding, they've given us an application, an actual website that we can log into now. Now we can start testing and executing our test cases from the test plans that we've created, validate that all of the requirements have been met, make sure all the functionality is working as expected, find as many bugs as we possibly can, which could be color scheme is incorrect, or if there's a user interface bug somewhere, a critical issue of people not being able to log out, maybe the users can't even register. There's so many mistakes that the developer can make and do make frequently. So as we're testing, we start to find bugs, and what we'll do is we'll report them into a bug tracking system, which is then assigned to a developer. They'll go in and they'll fix the bug, fix the issue, and assign it back to us. This is called a bug lifecycle. You may have noticed that I've mentioned test cases, test plans, and bugs. In the upcoming videos, we'll go into the bug lifecycle, iterating with developers, and how to write test plans and test cases. Up next, we'll talk about the deployment phase.
So actually, once the coding is done, this segment talked about the testing phase. So actually, testing phase is a very tough phase. what you need to do is you need to figure out test cases, that what are the cases that your system should go on with, what are the edge cases. So actually a lot of mind need to be applied in this particular stage, where you have to figure out things where your system can fail and figure out cases where it should pass. So a lot of investment is been done in this part also, to figure out. Writing test case actually is not a very simple thing, and a lot of emphasis has been done on how to write proper test cases and correct test cases. You have to take in account everything. What if a user has logged in but somebody can spoof it? Whatever if after 3-4 password attempts the system is not getting logged? All these things you need to take care in your test cases. This is also a very, very important thing. So you see, coding is one of the paradigm, but actually, there are a lot of things that happens outside the coding paradigm. And testing and designing are two very, very important aspects.
Deployment phase, the operations team will end up mirroring the staging or development environment systems that we've been testing in and get them ready for production, meaning that they'll install new hardware, brand new servers, have everything scalable for production. This includes
nowadays what is happening is that whenever you code any product and that product goes to a tester, there's an environment that is known as staging. So staging is some set of servers where the tester will deploy your application and test. So staging is basically a testing environment. You used to do end-to-end testing on staging, and once it is clear that tests are fine, then you move to production. So moving on to production means handling your application to the user.
Setting up the links, setting up the databases for real users, syncing up with the development teams and release managers. Once they've completed all of these tasks, our application will go live to real users. This brings us to the final phase of the SDLC, maintenance. So imagine that
we came to know that whenever we go about product, designing a product, we have a developer, we have a UX developer, then we have a tester. We also have one more segment that is called DevOps engineer. What does DevOps engineer do? So the responsibility of the DevOps engineer is to manage the servers. So how the deployment of your application on servers, the links where the clients can access the things, the load balance and all that. This is taken care by the DevOps team. So this is again a separate functional profile like we have a developer.
And our application became so successful. We're just getting millions of users logging in and registering and using this application. So we need to maintain the servers in the environment. They need to monitor that the load, the stress, everything coming on the servers by so many users logging in and using it, it doesn't bring down the system. Maybe we need to make larger servers, larger databases. Maybe we need to get faster.
This is what actually happens in maintenance. So when you roll out a system, you roll out with certain set of servers, certain set of databases. But what if the users increases? Suppose we have rolled out to 500 users and now the number of users has increased to 50,000. Of course, 3 servers and 2 databases will not be able to manage them. Then you have to maintain your system to make sure that, okay, it is still catering to users. So here is what a proper design comes into picture, that when you have designed it properly, you have analyzed the requirement properly, you know what system, what components to use, then it's become easy to maintain because you know that, okay, this is a design, we can increase the number of servers, or we can increase the number of databases, or we can increase more connections so that we can cater to users. So this is what basically is taken care into the maintenance phase.
Computers. There's a lot of stuff that goes on during the maintenance phase. There will be bugs found in production. It's called production support. Frequently, users will email with their issues, and you can stop and investigate what they're complaining about or what their issue is, figure it out, write up a bug, get it resolved, and do another deployment to production with the issues fixed. So to summarize, we've discussed planning, requirement analysis, design, implementation and coding, testing, deployment, and maintenance. All right, awesome. That wraps up the video on the SDLC. One last thing to say is once we're in the maintenance phase, new features will come through, new requirements will come through, and we'll restart the whole process again and be able to get new stuff added into our existing application.
So this is what the video spoke about, that how basically when a product is conceived, what are the things that happen. So maintenance is a very important phase. You might be seeing many people, if you're using any app, there will be a section like, if you have any error, report the error or send feedback. So all this comes into maintenance phase. When these things are come, a bug or a ticket is issued and this is assigned to developer to fix those things, or if your app has crashed and you send a feedback, then these things are taken very seriously and then the developer fix those things. So if new requirements too comes in maintenance, that okay, now we want this feature also, then this cycle again starts for the same product. So this is how basically a product is developed. This is how an idea of a product is conceived, and all these are all the things that happen. So today's stress is basically a design thing because this directly affects all the subsequent cycles. So let's move next.
In order.
So this is basically a system cycle, if you see here. So you see, software code is basically a very last level of what happens. Before it and after it, a lot of things happen when you design a system. As we saw in the video, we have requirement analysis, high-level design, low-level design. Then we go for test coding. And after coding, we have unit testing, we have component testing, we have integration testing, we have system testing, and then we have acceptance testing. So of all these things, the coding stands for only the last leg that we go. As I said, only 1/6 of the total phase is coding. Now we talked about system architecture. In system architecture, we spoke about analyzing the components that will be used and how those components will interact and what will happen. So when we drill further down, further more into details of the component, then that is called system design. So software design is the process of conceptualizing the software requirement into software implementation. So when you actually go about implementing those components, then you drill down further that, okay, what these components will contain, what were the classes this component will contain, how will I call the object of this component. Then when you talk about these things, this comes under the ambit of system design, where we actually drill down and start actually the actual component implementation. So architecture and design are difference by a very thin line. There's a very thin line between the system architecture and the system design. System architecture talks about high level components, how the things will interact, how your data will go. But system design drills into a bit more details of how actually those components will be coded, what will be the points on the components, what will be the interfaces, etc. So there's just a slight margin between a system architecture and a system design. Sometimes people conjunctionally use them as a similar thing, but there is a difference. There's a very slight difference between system architecture and system design. Though people generally club them together and call it as design. So when conceptualizing the software, the design process establishes a plan that takes the user requirement as challenges and works to identify optimum solutions. So designs are basically, is the entire intention of a system design or a system architecture is to make the thing easy for the developer to develop. Because you gather all the requirement and you actually optimize and conceptualize the components. So once you know the components, once you know the details of the component, it becomes easy for you to go with the system. So this plan should determine the best possible design for implementing the intended solution. So this is what is basically the gist of system design. Now, what are the artifacts of a system design? When we say that we want to design a system, what are the artifacts that we need to keep into consideration? So first, most important artifact is the software requirement specification. Unless you are not aware of a requirement, unless you are not aware that why the software will be used, who will use the software, what is the purpose, what is my user base, you won't be able to design the thing unless until you're aware of these things. Second comes the high level design. High level design, again, the component wise design that you're aware, okay, if I need to generate a very simple login system, what are the components I used to have? As we saw, we need to have a server, we need to have a user, we're going to have a browser, we're going to have a database, we are going to have an application service that will be running between the database and the server. So all these are high level design. And then we come to detailed design. Detailed design, as we said, we saw in the video that what coding languages to be used, how the checkboxes to appear, how the user edit will look, and how those components will be coded, means the internal of those components, what will be the database queries, how we will do joins of the database. So this is the detailed design that we formulate. So these three things comes into picture. You have to have these things when you come out as system design. So when we come to system design, it is a very important thing that comes into our mind, and that is a CAP theorem. So what actually is a CAP theorem? It is one of the fundamental theorem on which nowadays every organization is proceeding with designing their system. Actually, this question was asked to me in one of my interview questions. I remember there was a Dubai-based e-commerce company that was launching up, and they they were interviewing me for designing specific round was there at how you can design e-commerce system. So this was the first question they basically asked me, that what is CAP theorem and what you need to keep in mind when you are designing a system. So this is basically a very important theorem, and if students are aware of this theorem, and if you talk about this theorem in interviews or when you talk about this theorem in any discussion, this will going to help you a lot in giving a very positive image of your knowledge conveyance. So CAP theorem is something which we keep in mind when we design a system. So every software intelligence system has a software architecture. As we said, whenever you design any software, we need to have a software architecture. But the question is whether the architecture has been created in a clean, systematic way or just a random byproduct of software development. Whatever architecture we put it, that needs to be clean and systematic. We just cannot randomly come and design the components and randomly say that, okay, this will be the browser, this will be the servers, and this will be the interaction. No, we cannot do that randomly. Otherwise, we won't be able to produce a good system. The latter might not be too much of an issue. So whenever you are coming with whenever you're designing a very small scale system, like suppose you are designing a simple login system for only 50 or 100 users, then it is fine. You can go up with some design that just caters to. But suppose you're designing the same system for 50,000 users or 5 lakh users, you cannot move. So here what CAP theorem comes into picture, and CAP theorem specifies some of the laws, some of the rules that you need to keep in mind when you're designing a system. We'll talk about them in details. So for example, in Microsoft, I'll tell you one of examples. For example, take Vista as an example, Windows Vista. Windows Vista has lacked good architecture. And that is why this OS dwindled, and Microsoft did a lot of rework to completely redesign and come up with a new architecture. So Windows 7, 8, and 10. So this is an evolution thing, system designing, that each and every organization is coming up with. And CAP theorem is one of the way that we do about it. We talked about it. And so let's go about this theorem in detail. So nowadays, what we are having, before I go to CAP theorem, let's understand how basically systems nowadays are working. For example, take example of YouTube. So YouTube is a cloud-based distributed system where in India, if you're opening YouTube, you're able to open it. Somebody, if he's sitting in Delhi, he's trying to open YouTube, he's able to open it. So why this is happening? How everybody is able to open YouTube from all places? Because we have the YouTube servers are distributed. It's a distributed system where servers are distributed different places. If somebody is in Mumbai, he's typing youtube.com, he will be routed to the nearest server. For example, servers may be in Hyderabad, is located in Hyderabad. So a user in YouTube may be routed to a server in Hyderabad who is catering to his needs. Similarly, if someone is in Delhi, if he's typing YouTube, he will be routed to a server which is nearby so that his requests are, delivered on time. So many cases happen. Why we go for a distributed system? Why we distribute the servers? So that first, the latency time that is incurred in network cost gets reduced. You used to get your result fast. And second, if one server goes down, suppose you are in Mumbai and you are typing youtube.com or you are watching YouTube videos, you are getting all your requests from a server in Hyderabad. But what if the Hyderabad server goes down? If it fails, if there's a power cut happens, YouTube cannot stop. You cannot see that, oh, sorry, we cannot render, there's a power failure. No, this will redirect to a second server so that your request is still handled. This is what we call availability. Your system should be available. So YouTube is one of a system that requires more of an availability. So we'll talk about such systems, and CAP theorem is what basically is talked about it. So CAP theorem basically is a tool used to make system designer aware of the trade-offs while designing network shared data system. So see, whenever you design a system that is distributed, whenever you design a system that has data, whenever you design a system that needs network, you have to come up with certain trade-offs. You cannot provide everything to user, right? You cannot provide everything to user. You have to come up with certain trade-offs. Like, okay, if the network is gone, then I will provide this to my user. Or if the network is there, I will provide this to my user. You cannot provide everything to the user in today's environment. That is why the designing phase is very important, because where you have to come up with a decision that what all you need to provide to the user and what are the trade-offs that will be required. So what are these trade-offs and what we actually go for and what we look for, we'll see in the subsequent slides. So what is cap theorem basically? So cap theorem is a fundamental theorem in distributed system that states that any distribution system can have at most two of the following three things: either consistency, availability, or partition tolerance. Out of the three things, you can have only two for a system. You cannot have all the three things together. Now, what is consistency? What is availability? And what is partition tolerance? That will talk in subsequent slides. But whatever things that we are using nowadays, WhatsApp, Facebook, YouTube, cloud-based, whatever online things that we're using, all are distributed system and all has to follow the three things: consistency, availability, or part tolerance. Even the banking system, when you do banking transactions, this is also a huge system. This is a distributed system. So many users are there. So the banking system also has to choose between these three. So what you need to choose is basically your requirement. Like what is your requirement? So based on your requirement, you need to choose between these three. For example, let's talk about availability. So of the three things, let's go on each one by one. So what is consistency? When we talk about consistency in a system, consistency means that all clients see the same data at the same time, no matter which node they connected to. For this to happen, whenever data is written in one node, it must be instantly forwarded and replicated to all other nodes before it is deemed successful. So the idea is that whatever data you see, you should be able to get the same data everywhere. A biggest example of a consistent system is the banking system. Suppose you log into your bank account and you just log into your account. You should see your account balance. That account balance has to be same whenever you log from any server. Suppose you log in from Mumbai, you are redirected to the Hyderabad server. You are seeing your amount as rupees 100. Now suppose you travel to Delhi, you logged in. The Delhi will redirect to a different server. So there also you should see your balance as 100. It's not that in that server you see a different balance. No, it has to be consistent. Your actual balance should percolate to all the systems, all the servers, so that you see the same data. So this is a very important thing, consistency. And banking is a very big example. I think the best example of a consistent system that has to be consistent. If you're seeing 100 rupees in a Delhi server, when you're logging from Delhi, you should see 100 rupees when you're logging from US also. Or if you do a transaction, you transfer 10 rupees from your 100 rupees, you should see 90 from every place. So this is what is consistency. So this is a very good example. I just try to know about consistency. Suppose this is your client, UCell, and these are your system server that are located. Suppose G1 and G2 is your server, and the data for your data in the server is V0 and V0. Okay. Now suppose you update the your data at server G1. You replace V0 by V1, and you get an acknowledgement that it is done. Your data has been uploaded at server V1. But now, when you will read from G2, you will still get V0 because the same has not been updated on G2. So data you have updated to V1, but when you are querying G2, you are getting data as V0. So this is not a consistent system. You are getting a different data. This is against the rules of consistency. You should get the same data. This is how consistency is achieved. So you have updated on G1. G1 has become V1. Now G1 communicates to G2 that the value has changed to V1. G2 updates it to V1, send an acknowledgement to G1. Then G1 sends an acknowledgement to client that, okay, now only your data is updated. So in a consistent system, when you change your data in a particular server, your data will be called as updated only if the update has happened on all other servers from where you can query. So the system maintains list of servers or list of points. So whenever the updation has happened in all places, then only you get a proper acknowledgement, okay, the updation has happened. So then you see if you query G2 now from a different place, you will get V1. So this is a consistent system. So what happens in banking system? So banking system has distributed systems. They have servers at different places. Your data is replicated to different places. So what happens if one server goes down? You will not be allowed to do a transaction. Suppose you log into Bank of India site, you log in, you try to do a transaction. But if suppose it has two servers, only G1 and G2. Suppose by any chance, if G1 is not able to update the data on G2, your data will not be uploaded. You will see an error message that try after some time, some error happens, it cannot be updated. So that update will happen only if your data is updated in all the points, in all the services, in order to ensure consistency. So this is how we, ensure consistency, and this is how a consistent system basically works. Second is availability. Availability means that any client makes a request for data, gets a response if one or more nodes are down. As I said, example of YouTube. If you're querying YouTube from Mumbai, Hyderabad server is processing a request. If suppose the Hyderabad server goes down, it's not that should not open on your system. It should still open your system, but the response will get will be from a different server. It will be routed to a different server. So this is availability. YouTube is an example of an availability system where it should be up and running. No, not so. Don't. It doesn't matter whether your server is down or not. It should always be up and running for the client. But here, consistency does not matter. So here is a trade-off. For banking, availability is not necessary. If any server is down, the banking system will be down because they cannot have inconsistent data. But for YouTube, consistency does not matter. It doesn't matter if the same video is present on this server or is not present on other server. The only matter for YouTube is that I should be up and running to the user. So YouTube is an example of an available system. Same is for Facebook. Facebook is also an example of an available system. Because when you type www.facebook.com, you are able to log into Facebook, you are able to do the Facebooking. It doesn't matter what data you see, what updates or what post you see. Maybe you can see them later when the server is up. So this is what a trade-off has been done. That okay, I need to go for a consistent system or I need to go an available system. The third thing is partition tolerance. So a partition is a communication break within a distributed system, a lost or temporary delayed connection between two nodes. So as you saw, nowadays all systems are designed in a way to be distributed in nature. All systems interact with servers, and all servers are distributed to different locations. So there's a very high possibility that two servers are not able to communicate. There is a network breakdown between the two servers. So the idea is that a partition tolerant system is such which continues to work even if there is a breakdown between the system. You should still be able to cater to the need. That is the example of a partition tolerant system. So one system able to correct availability despite the breakdown. So if there's a breakdown between G1 and G2, still the client is able to interact with either G1 or either G2. So the breakdown is not affecting client interaction. So this is what is the example because there is no link between G1 and G2. So this is an example of a partition tolerant system. These are the three things that we always need to keep in mind when we are developing a system that is distributed, that is have a lot of users, and that is catering to data. So of these things you need to keep in mind basically what type of thing you need to undergo. You need to make sure consistency, or you need to make sure availability, or you need to make sure partition tolerance. So I think this is what is gap theorem, that you can have only two things at a time. You can either have consistency or availability along with partition tolerance, or you can have partition tolerance or actually I'll just show it again. See, so consistency, availability, and partition. So at most you can have only two things can overlap. You cannot have all the three together. So this is what is the entire base on which today's systems are generated and built upon. Let's talk about high level design. So what is a high level design? So as I told that designing again breakdowns to two very important things, a high level design and a low level design. So high level design is generally a system design which includes the description of the following parts. It includes the description of a system architecture, database design, a brief mention of all the platform, systems, services, and processes the product would depend on, brief descriptions of relationships between the modules and system features. So all the data flow, flow charts, data structures, etc., are in these docs, and which the developer can understand are part of the high-level design. We usually propose things that okay, since our user need to log in, so we will take his name in an array. So this is a high-level design. This will get stored in a database. We will use a MySQL database. So these information are part of high-level design. Low-level design. So what is a low-level design? So low-level is a component level design process that follows a step-by-step refinement process. Okay, you have already said that you will use a MySQL database. You said that you will use array to store the username, all these things. But now actually how you will create the tables in a database, what will be the fields in the table, how will the table interact, what will be the joins, what will be the primary key, what will be the secondary key. These are now finer details. So these are termed as low-level design, basically. So if you are storing an array, then how you are storing in the array, what is the program you will write, you will be using loops, you will be running loops, how you take the information. So all these in-depth are part of low-level design. So it is based on high level design, but digs deeper, going into the separate modules and features for every program in order to implement a specification. So this is what we talked about, a low level design. So a low level design comes only from a high level design. You propose a high level design, you propose a component, and in low level design, you propose final details of the component. So these are the basic things. So in designing, whenever you go for system design, first you need to do a proper requirement analysis. Then you have to understand the gap theorem module of your system, that okay, we need to go for an available system or need to go for a consistent system. And when these things are clear, then you basically look for the level of designing. You first propose a high level design. So there's a job profile that is very, very important nowadays and is in great demand, is of a system architects or principal engineer that we call basically. So when you go to an engineering stream, you go to an engineer, then you become a senior engineer, then you become a lead engineer. So from lead engineer, you get a bifurcation, whether you go for a principal engineer or you go to an engineer manager. So when you go to engineer manager, you need to lead a team and do all the technical aspects of that. But when you go to a principal engineer, you basically go into designing, where when the product requirements come, you need to propose the design, high level design, that what are the components you will use, what type of databases you will use, what type of caching technology you will use, so that those are optimized, so that they can be maintained, and so that if 7 years, leave 7 years, if one year or 1.5 years, if the technology changes, then whether that system can be changed or modified with minimal effort to get accustomed to this technology. So this is what the role of a principal engineer becomes. And from principal engineer, then you go to a principal architect. And then the principal architect becomes sole decision maker that how you can go about a software and all that. So it's a very important profile, and it is actually in great demand, and companies are greatly looking for someone who has a very good experience in designing or a principal level, requirements. So we talked about the basics of system architecture. We talked about what is a system architecture. We talked about what is a system design. We talked about gap theorem, that what is a consistent system, what is an available system, and what is a fault tolerant system. We talked a brief about the high level design. We talked a brief about low level design. So now here's a very interesting video. This question actually was asked in system designing and this is also a very famous interview question that is basically asked when anybody, even in Microsoft, this question is asked. So how a tutor was designed. So when the tutor company came with this idea of developing tutor, so how it was designed, what were the things taken into consideration. So this gives you an idea of a high level design, an architecture of tutor, that how tutor was architectured, what were the components used, how the components interact with themselves, and how the users will be done in algorithms. So it's a very interesting video, a very short video, but a very insightful video. So this will give a very clear picture of how we proceed with system architecting. So let's start this video.
Hey, how's it going, everyone? Welcome to another video.
It's audible?
Yes, okay. Engineer Shaurya, it's
audible. Yeah, okay, fine, thank you.
And today we're going to be talking about how to tackle the system design interview. Now, if you have an on-site interview, you are most likely going to be having one interview dedicated to the system design interview. Now, this is an interview where they really want to see you take control of the conversation. They're going to ask you to design some sort of system, and this is kind of where a lot of people get stuck because they don't really know how to approach the problem. They don't really know how to kind of what steps they should take, and it's a really hard interview to study.
So basically what happens nowadays is whenever somebody tells you that, okay, let's take example of interview questions, or suppose if I ask any student that, okay, can you just design a system, a simple search engine, that how search is happening. So many people are not aware of the approach, that because they're not aware of the concept of system architecture. So whenever you go with a design, you need to follow concept of HDL and LDL. That okay, you first need to conceptualize a high level design. That okay, if I need to develop a search engine, what are the things I need? Who are the users to which the user will interact? What are the components will be there? So you need to get these things in mind and then establish a connection between these components. And then finally propose an architecture. And when that architecture looks good, then you can talk about a low level design of that. So in this video, we'll see how, if you are asked to design Twitter, what are the things that should come to the mind, how we can, proceed with the architecture, how we can select the components, how we can establish a communication between the components.
For just because of how many different directions the interview can go in. Now, we don't have an interviewer ourselves, so we're going to have to make some assumptions, but we're going to do our best to simulate a real interview. And the example that I'm going to use is actually going to be from an interview question that I got myself. Now, the problem is going to be designing Twitter. And this is a problem that I got last year when I was interviewing at Zillow. It was the first of 4 interviews, and it was actually with the hiring manager. So without further ado, let's take a look at the roadmap. All right, so as I mentioned, we're going to be designing Twitter. Initially, we're going to look at the requirements and goals. So what are we actually building here? What do we want the outcome of it to be? And then number 2 is going to be storage and network capacity. How much space do we estimate our system to require? And as well as how much network is going to be going through our system. Number 3 is going to be system APIs. What kind of data is our system going to be consuming? Number 4 is going to be a high-level design. So how are the components in our system going to be working with each other? And finally, we're going to get into the database schema and data modeling. Also, I forgot to mention, we're going to be tackling a couple more advanced topics, which are going to be data sharding as well as caching. So in the first part, we need to define our requirements and our goals because we need to know what we're building before we actually go in and build it. So this is going to be split up in 2 parts, functional and non-functional requirements. So for our functional requirements, we want a user to be able to post tweets, follow other users, favorite tweets, and also be able to have a timeline, which will be generated off of the tweets that the user follows. So for non-functional requirements, these are going to differ as in they're not actual actions that the user can do, but they're requirements that we want the system to have. So the first thing is we want the system to be highly available. This means that basically at any time in the day, a user should be able to go on and they should be able to access their tweets. We want the system.
Functional requirements are those requirements that user will give you, that what the user wants, that will come in the requirement analysis phase. That okay, I should be able to post a tweet, I should be able to follow a user, I should be able to tag favorites to my tweets, I should be able to set timing. Non-functional is now what we as a designer or engineer, what we feel, whether it should be a highly available system, it should be a low latency system. So these are which CAP theorem comes in mind, whether we now do a trade-off, it has to be an available system or it has to be a consistent system. These are non-functional requirements. These are basically technical requirements, and functional requirements are basically user-based requirements.
To have low latency, so we don't want it to take forever for them to load up their timeline or go to their profile page. We are okay with our consistency taking a hit. So say a user posts a tweet, we don't need it to immediately be available to all users. It's okay if this takes a few seconds. Now, when you're writing these requirements,
he has clearly mentioned that we want our system to be available system, but consistency, it's fine that if I have posted a tweet, if it is not getting updated quickly to all users, it is fine. So he has taken a trade-off. He has taken availability and partition tolerance as an agenda for design Twitter.
Don't expect to be able to implement all of these within your interview. You want to really write as much as you can down just to show the interviewer that you are thinking about these things. So I would say it's better to have more requirements that you probably won't get into than not having enough. So that's requirements and goals. Let's go to the next section. So in the next section, we're going to be talking about storage and network capacity. Obviously, Twitter is a massive platform. So for this part, we're going to have to just make some general assumptions. So let's assume that our platform has...
Before we actually go about how to design a system, we first need to understand the users, that how many users we can expect, how many daily users will come there, how many monthly users will come there. So what happens in companies like Microsoft and Amazon and other stuff is that whenever we go about designing a system, there used to be a marketing team and there used to be a product team. It is their responsibility to gather all this information. Suppose they're coming up with a new product. They used to gather all information that how much users we can expect or how much users we can be able to generate in or gather in. So these requirements, they pass into the product management. Then the product management team actually creates the products based on the user and all that. So the team comes and says that, oh, see, you're going to have 1 billion users. Then the product manager will think in a different direction at how we can productize it. Similarly, if it comes and says that we're going to have only 500 users, then a very different approach will be taken. So it's very important to understand the usability before developing a system, that basically how many of the users, how many will be active users, how many will be daily users. If you don't know this data, you won't be able to come up with an optimized or an architecture, a proper architecture. This is very important. This should be the start before you build any system.
1 billion users. We have 200 million daily active users. We have 100 million tweets per day, and we have an average of 200 followers per person. So let's measure
this we have assumed that, okay, so since Twitter is a huge system, and if I need to design Twitter-like system, then okay, I should be getting 1 billion users. There will be 200 million daily active users, these people who are daily using Twitter. There will be around 100 million tweets per day, and there will be about 200 average 200 followers per user. So these data now we have in mind. Now, based on these data, we can calculate the capacity of the system. How we can calculate the capacity of the system? This is a very simple data that actually I'm saying just for understanding purpose. In real world, there used to be a lot of data, and we need to analyze a lot of data to actually judge the capacity of the system. So it's just for understanding this, a very simple data. So let's see how we actually calculate the capacity of the system.
Storage that we'll need for our tweets. So if we have 100 million tweets, and let's say each tweet is going to be 140 characters, and we'll assume that it's 2 bytes per character. So it's going to be 100 million times 280. And we also need, let's say, about 30 bytes to store things like ID, timestamp, user ID, etc. So let's give us additional 30 bytes there. So this is going to be about 30 gigabytes that we need per day. So if we want to multiply that by 365, 30 times 365, this is going to be about 11 terabytes per day, per year. And then if we want to multiply that by 5, we're going to need 55 terabytes of data for 5 years for just our tweets. If you think about it, that's really not that bad for a company like Twitter, 55 terabytes.
So you see one thing, we calculated the size of texts that we can get based on 100 million users. But see, based on, 100 million tweets. So we got around 11 TB. But see, the plan is that we have to design a system to cater to 55 TB. We have to think 5 years down the line. So this is how the system architecting is done. So when you are developing a system, it's not based on the current need only. You have to think 2 years, 3 years, 5 years down the line, and then design the system so that if the number of users become 55 from 11, still your system should be able to manage them. You need not to spend much on re-evaluating system and maintaining your system again and investing more on it. So this is what the stress is on.
Really pretty small, actually. So in terms of what our bandwidth is going to be, let's assume that we have 10 billion tweet views per day. So for that, what we need to do is we need to multiply 10 billion times however many characters we have, or however many bytes we have. Remember, we have 140 characters, 280 bytes. And then let's divide it by the number of seconds in a day. So that's going to be 86,400 seconds per day, which if we add it up, or if we do this calculation here, it's going to be about 32 megabytes of throughput per second. So that's something that we're going to be needing to think about later down the line if we want to scale our app. All right, this takes us to our next section.
Network bandwidth, we have calculated, okay, if this much tweet will going to happen, then per second we need 32 Mbps of network bandwidth that our servers should support to get this much of tweets. So see, this is how we are slowly drilling down to the requirements. Now we come to system APIs. So in general, what are APIs? APIs are basically endpoints that we provide to the user. Suppose you have www.facebook.com/id/423. So if you hit that, it will open someone's profile. So this id/423 is the API that they provided. If you hit this endpoint, you will get this data. So APIs are basically endpoints that are provided. If you do browse using a web service or hit those endpoints, you're going to get certain things from our system.
Which is going to be system APIs. So once we finalize the requirements, it's always a good idea to define the system APIs. And these should explicitly state what is expected from the system. And we can use either SOAP or REST to expose the functionality of our service. So one example of an API call would be a tweet, and this would be a post, and it's going to take...
Most of you will be aware of the network coordinator. So whenever you want to put any data to a server from web, then you do a post call. So for designs as Twitter, we need to get a post call. So he defined the API like tweet, where we will be sending tweet data and all these. And this will send us the new tweet. If you want to see any tweet, so we will be sending the tweet ID and it will send us the tweet. So this is what we designed this API.
In 3 arguments. So the first is going to be the developer key, so we can keep track of who's actually making this call. We can have the tweet data, which is going to be something like probably like the 140 characters of what the actual tweet is. And then we can send in something else like the location of the user that is sending the tweet. And what this would return is going to be a URL of the new tweet. Another API call we have is also called tweet, and this is going to be a get. Again, it's going to have that key, and it's also going to have the ID of a tweet. And what that's going to do is return information about the tweet, and you could have it return in a format of your choice. I chose JSON in this case. So that covers the system API section. This is definitely...
So we want 2 functionalities for this system. First, we should be able to tweet. So when we tweet, we will calling the first API, that is a tweet API, where we'll be sending a key. That these are some extra data that we send just for proper information. And we send the tweet data. So these tweets data gets stored in our databases, and we in return get a URL. So this URL is a URL filtered so that you can share it with anyone else. Similarly, when you want to fetch any tweet, we just go and click the tweet. So when you click the tweet, a tweet ID of that tweet is passed to this tweet API, and then you will get information on that tweet.
Something that if you are comfortable with APIs, this is something that you might want to go more into detail with, but it's definitely something that should be discussed during the interview. All right, so getting into the fun part now, we're actually going to be drawing our system, and we're going to be drawing all the different components and how they're going to work with each other. So initially, we're going to have our client on the left. So this could be something that's coming in from the web browser. We have our server, which is going to be consuming the API call.
So this is a very, very, very basic high-level design of a Twitter. You are going to have a client. The client will type www.twitter.com. This will go to a server. The server will take your request. If you want to get a tweet, the server will then talk with the database, and the server will then get the result from the database and send it to the client. So this is a very, very basic, a very naive high-level design.
From the client, and it's going to be saving to a database. And I also wrote this file storage here just in case if some tweets can have pictures, video, so we need a place to store that as well. But the problem here is, as like we talked about scaling before, one server is not going to be able to handle all the load that is going to be coming in from our clients. So
now you have already identified the users. Now, if you are using one server is not going to handle 5 billion requests. You have to scale the system. So scaling again is a very important topic. We'll see if we can take this topic next is scaling, where we understand the fundamental scaling and how we can scale a system to users. So here in this design, as you see, you will be having 5 billion users, and just having one server, it won't affect. So you have to architect, design in a way that it should be able to sustain those users.
What we can do here is have a load balancer between our client and server. So what I've done here is implemented a load balancer. We've also replicated our servers into a server cluster here. So now when traffic comes in from the client, it's initially going to go to a load balancer.
So what we changed the design is that we introduced load balancer. So as I gave an example that someone is in Mumbai, if he's opening YouTube, he's getting from Hyderabad server. Now if the Hyderabad server goes down, he's getting it from the Delhi server. So this is handled by load balancer. So load balancer sees that if one server has gone down, it sends the load to another server that is up and running. This is taken care of by load balancer. Load balancer again is a very important topic. It's a separate topic in itself. How there are algorithms for load balancing. There are a lot of load balancers work in a very different algorithms. AWS has a different set of load balancer. Azure uses a different concept for load balancer. So just to get an insight, load balancer is basically a component that is running that helps direct the request to the correct server. So this is the architect that we thought that since the number of users are very high, one server won't be using. So we will use a load balancer and we will have a set of servers. So within that only the load balancer will keep on sending the requests.
balancer, which is going to distribute the traffic between the different servers. So that way, instead of everything going into one server, now it's going to be split up in between 3 servers. So that way our system will be able to better handle that high traffic. So in the next section, we're going to be talking about our database schema and how we're going to be modeling our data. So we need to be able to I'm thinking that we're going to use.
So earlier design was a high level design because we just talk about the component. Now here we are talking about database schema. We had drilled out furthermore. So this is an example of an LDL, low level design.
4 different tables here. So for our tweet, we want to have the ID of the tweet, which is going to be our primary key. We want to have the user of who is actually creating the tweet. We want to store the latitude and longitude. We want to store the create date, and we want to store the number of times this particular tweet has been favorited. The next table is going to be our user table. So we want to again have the primary key of the ID. And then in here, just kind of things that I thought of were the name, the email, the date of birth, and the last time they've logged in. So the next table here is going to be user follow, and it only has 2 values, user 1 and user 2. Since following is it's not bi-directional, so it's not like Facebook where if you guys are friends of each other. If you follow someone, that person doesn't necessarily follow you back. That's why we only need user 1 and user 2. And this is going to assume that user 1 is following user 2. So if we have something in here that was like, say, user 10 and user 20, this is assuming that 10 is following 20. And finally, we have our favorites table. And this is again going to take 2 fields here. It's going to be the tweet ID and the user, or the ID of the user who liked the tweet. Now at this point, the interviewer obviously could ask you more questions about this. In past interviews, I've actually had interviewers ask me to do certain queries based on these tables. So if you are kind of weak at SQL or you need to brush up on it, I highly suggest you do that because you may be asked to actually do some kind of gets or joins based on these tables here. All right, so the next section here is going to be more of an advanced topic. Since we know we're going to have a huge number of new tweets every day and our read load is really heavy, we need to find a way to distribute our data onto multiple machines so that we can read it.
Like we have different servers. The load balancer can distribute your request to different servers. Similarly, there's a concept of data sharding where you can distribute data to different databases, because one single database also cannot take 5 billion or billions of data. It is also has a limitation. So there's a concept of data sharding. This we can plan up next about. It's also a very interesting topic that is going on. So there's a concept of data sharding where we distribute data among different databases so that the load per database is also less. Similar fashion, like we need to take care of load on server, we also need to take care of load on databases.
Right, efficiently. Now there are a few ways to shard your data, and this is basically splitting your data up onto different machines. So the first technique is going to be sharding it based on user ID. So say we split our database up into 2 sections, and say we want everything from like A to M on this database and everything from N to Z here. So in this method, we would have our server here, and then we'd have again some kind of like load balancer in here that would that the server would go to initially, and this would route it based on the appropriate database. Another thing we can do is shard.
We have a load balancer for data servers. We can have a load balancer for databases also. So these are very interesting topics. I just try to understand the basics here. Details can be taken next.
Based on the tweet ID, so we can have some kind of hash function here. So basically, it'll be like some kind of box, and the ID would come in here, and that way it would know which database it's stored on. So this would be some kind of hash function. And then here, based on the hash function, we can like mod it by the number of servers, or sorry, the number of databases. And then based on that, it would go to the appropriate database. A couple other things just to go over quickly is we can shard based on the creation time of the tweet. That way, It gives us an advantage when we're fetching the top tweets quickly, because we know that the top ones are going to be the most recent ones. We can do things like combine the tweet ID and the tweet creation time there. So there are definitely different ways that you can shard your data, and it just kind of depends on the trade-offs and kind of like what applies better to your system. So the final section that we're going to go over is caching. Now, as we see in this diagram here, we have our app servers here, and they are talking to our database. To speed this up, what we can do is cache our hot tweets